Let's learn how to do regression lines, or in other words, line of best fit on the calculator. But first, we're going to need a little bit of data. All right, so here's some data. X coordinate, Y coordinates. Again, it's just ordered pairs. So you could graph the 0.14 and the 0.27 just on a regular graph. Okay, so we know how to enter functions into the calculator, but how do we enter individual points? Because that's different. So we go to stat, enter, or 1, and we're going to put all the x values in L1 and all the y values in L2. Notice this does look similar to the table, but the table is x, and if there's a function, y1, y2, y3, etc. But under stat enter, it's L1, L2. The L stands for list, as in lists of data. Now, if you already have any information there, we're going to go up here and we're going to put the cursor on the name of the list. That way we can affect the entire thing. So what I want to do is get rid of all this. Now, I don't want to hit delete. If I do, that happens, and L1 is just totally gone. I don't want that. Now I can insert L1 back in, but it's just easier not to do that. So instead, with the cursor on the name of the list, I'll hit clear, enter, and there's other ways to do it, but my way works fine. And then I'll put the data into the calculator, the x values in L1 and the y values in L2. Okay, now let's see what they look like. Okay, if we go to graph, we don't see anything. Why is that? Because we need to go to y equals and arrow up to plot 1 to turn on the plot. Notice plot 1 now looks different than the other two. Now if I hit graph, I'm going to see some points. But back on stat enter, there were 1, 2, 3, 4 points. I only see 3. Well, that's because one of them's off screen. Okay. In fact, it's the one with the y value of 14, because right now I'm on zoom 6, so the top of the screen only goes up to 10. So I could go to window and push up that that y max to like 15, and then I can see it for sure. Okay, and there's that other point. Or I could do another trick that works quite nice. Anytime you're graphing points, and this trick does not work for functions, just points, but if you're graphing points, you can go zoom and then option 9, okay? Because we did go to the stat button, so zoom stat. And then it just zooms right in on those points quite nicely. So that's a nice thing. So this is the scatter plot of those points, and that's what they look like. So what we're going to do is we're going to find the line of best fit for them. And it, I don't know exactly where it's going to be, but, maybe it's, about right there, for example. That's probably about where it is, because the line of best fit or regression line will follow the pattern of the points. Doesn't mean it'll go through all the points. It usually doesn't. It doesn't even mean it'll go through any of the points. It might not go through any of them perfectly well. But it will be the line that best follows the pattern of the points. Okay, so actually, you know what? Why don't we just leave that there and see how well I did. So let's see how to do that. So we'll go stat, and then this time right arrow, and we want to pick linear regression, as in straight line. I want to get the straight line that best matches those points. Okay. Okay, so I'll go calculate, and that straight line that best matches the points is going to be y equals a, which is 3.2, so 3.2x, plus b, which is 0.5. Now, a cool trick we can do is we can go to stat right 4 again, but this time we can tell the calculator to store the regression equation in the y equals menu by going alpha, trace, and then this cool pop-up window appears, and I'll pick y1. So that tells the calculator, hey, store this equation in y1 when you get it. So I hit enter. That's what I saw before, but in y equals, there it is. Okay, there's my equation. Just looking incredibly beautiful and shiny. So when I go to the graph, it'll now graph the line of best fit. And I was pretty darn close. I didn't expect to be perfect, but pretty close. So let's get rid of that. And you'll notice this line of best fit does not go through any of the points exactly. It's pretty close here, but it doesn't quite go through the center of the point. And that's fine. There's nothing wrong with that. Okay. If your line does go through all the points, then that's when you typically become suspicious of the data that, maybe that data, is not true or was collected poorly or something. Okay. Let's go back to stat right 4 again. And this time, let's look at this. Notice we've got the R and the R squared. Okay, these guys are two related measurements of how good of a fit the line that we found is for the points. How closely does it match up? Well, I think we can agree that this line follows that pattern very closely. Okay, because those points, the 4 points, form almost a perfectly straight line. Okay, whoops, not that. There we go. However, because the line does not follow the points perfectly well, R squared is not 1. If R squared is exactly 1, then that means the line is a perfect fit for the points. But that's not the case here. And that's fine. But it is pretty close to 1, suggesting that the line is a very good fit. Okay. You could also just look at R. The closer the R is to, or R, the closer the R is to 1 or -1, the better the fit. And the closer the R is to 0, the worse the fit. So if you get an R value of like 0.1 or something, then that means that your points are just, they're just all over the map, and there's no straight line pattern. And so that the line of best fit is, maybe something like that. And it doesn't fit the point, it doesn't fit the pattern of the points very well because there is no straight line pattern for those points. So that's kind of the idea there. Anyway, that is how to do it. So get practicing.